Hello. In this video, we will give a conceptual overview of Markov models and show how they are used with a text generation example. For this video, you will need a basic familiarity with computational thinking, which may include a background in math or some programming experience. However, this video does not assume knowledge of any particular programming language or knowledge of advanced maths such as graph theory. By the end of this video, you should have a conceptual understanding of Markov models and an example of how to use Markov models. Please note that this video will not go into the formal probabilistic or graph representation of Markov models or Markov chains. First, let's define Markov models. Markov models are a model of prediction where a future event only depends on previous events. Different order Markov models consider different numbers of previous events in the prediction model. For example, a second-order Markov model considers the two previous events when predicting the next event. This will make more sense as we walk through an example with text generation. In our example, we will first generate a Markov model using input text data. After we finish processing the input data, we will use the model to produce some new text. To create our Markov model, we will read the input text and keep track of how often a word shows up after an order number of words. After reading in the entire input text, we normalize the word counts to create probabilities. To make sense of this, let's go through an example of this for a second-order Markov model using abstracts of some scientific papers. As we read through a paper, for every two-word phrase in the paper, we keep track of the word that follows this phrase. For example, after the phrase, the virus, we saw the word had 10 times, structure 6 times, and rapidly 2 times. We store these counts in a table for every possible word in every two-word phrase we come across. We'll also keep track of the total number of times that we saw each two-word phrase, which you may note is just the sum of that row. After going through the entire input text, we need to normalize the values in each row. We do so by dividing each entry in a row by the total counts for that row to create a probability for each word. Let's consider the virus row. Since we saw the phrase, the virus, 31 times total in the input text, we divide each value in that row by 31. This gives us the probabilities in the model. For example, when we see the phrase the virus, there is a 19.4% chance the next word is structure. We do this for all the rows in the table, or for all the two-word phrases that we saw in the input text. We have finished creating the Markov model. Now, we want to use this model to generate some text. To do so, we first have to choose a seed. The number of words in our seed depends on the order of the Markov model. So for our third-order Markov model, we need 3 words. After we have our seed, we look up the corresponding entry for those words in the table. Based on the probabilities and words in that row in the table, we choose our next word. This chosen word becomes part of our new seed, and we repeat the lookup and choosing process until we have chosen our desired amount of words. This process is sometimes referred to as a random walk. Let's walk through an example using our second-order Markov model we just generated. Since we have a second-order Markov model, our seed needs to be 2 words. We'll choose the phrase, the structure. We now need to look up this phrase in our table. This row tells us the probability of each possible new word to add to our output. Let's visualize this. Here on the left, we have our seed, the words, this structure. From there, we have different options with different likelihoods. We have a 27.7% chance of choosing the word rapidly, a 14.9% chance of choosing the word had, and a 57.4% chance of choosing some other word, which we didn't show in the table. Let's say the computer chose the word had. Now our new 2-word seed is structure had. We then fetch the probabilities for different possible new words after this phrase. In this case, our new choices are the words 6, weekend, or fit. We repeat this process of choosing words according to their probabilities from the Markov model until we've produced the amount of words we desire. Here's an example output of this model. Tick-borne encephalitis virus vaccine against highly pathogenic flavivirus that has been in auditory, visual, or physical contact. We've investigated the effect of the disease. As you can see, the sentence is mostly grammatically correct, but the content doesn't quite make sense since it was randomly generated. This concludes our example of a Markov model. There are many real-world applications of Markov models, including for music generation and weather prediction. Thanks for listening, and please leave any questions in the comments.